ஹலோ சொல்லுவோம். ம் வந்துருச்சா? ஓகே, ஐ திங்க் we are live. So hello everyone, we'll start the stream by 4 o'clock, 4 p.m. We'll wait till then. So hello everyone. I think we are good to start. So we'll start now. So first of all, before starting, I'd like to apologize for the fact that when we conducted the orientation last week, the meet limit was limited up to like only 100 members. So I think around 30 people were waiting outside the meet. They couldn't join because the meet limit is 100, so it exceeded the limit. So meet did not allow around 30 people. So that's exactly why we have chose to go with YouTube and then stream the entire session in YouTube so that everyone can watch. Okay, so I think we'll start with this. Okay, so I just want to know if everything is all right. So just put in the chat if you have any problems hearing me talking, or if you cannot see the stream, or like any jittery or any problems. I'll wait for 1 more minute. Type it in chat if you have any issues. We'll start after that. If there are no issues, then we'll start. And before proceeding, if you want, you can share this with your friends so that they'll also get benefited. So can I get something in the chat like hello, yes, everything's fine, your voice is clear, or your voice is not clear, I cannot hear your voice, something like that would do. Yeah, no issues, you may proceed. Okay, sir. So I got one reply. I'll just wait for 30 seconds more, so I'll start after that. Okay, everything's fine, Bruce fine, thank you. So if you guys have any doubt, yeah, if you guys have any doubt, you can post it in the chat. If I see them, I'll answer that. Or if I complete one subtopic, I'll take all the questions and then I'll try to answer that after that one subtopic is completed. Or also at the end of the stream, I can answer that. So the thing is, I will not be able to see the chat and then do this session concurrently. So we also have chat moderators who will take care of this. Okay, so first we'll proceed with this. So on the basic level, I think you guys are here to learn about STL, which is C++ library, standard template library. So the prerequisites, I like to say something about the prerequisites. We actually put nil as prerequisite, but we do want something for you to know. First thing that you need to know is loops, right? So how to write loops. So this includes a for loop, while loop, and do while loops. And then another prerequisite is obviously to write functions, right? So if you guys know these two things, we are good to go. So if you guys don't know loops or functions, that you are very new, that you're fresher, that you don't know that, you may tell that now. I'll spend like 2 or 3 minutes to explain how a loop works and how a function works, so that we'll proceed with what is STL, and then we'll proceed. So do you want me to explain what loops and functions are? Are we good to go? Like, do you guys already know what loops and functions are? In any programming language would be fine, but since we are taking C++, if it is better if you know to how to write a loop and function in C++. I'll wait for 30 seconds so that yeah, we know loops, they are good to go. Okay, fine. So I guess we'll proceed with the loops. Okay, so since you guys already know loops and functions, we'll be at first we'll be covering two things called const t ampersand. So we'll check what a reference is basically. So what a reference is, and then what does const do to a object or a variable in during runtime. So we'll do this one, and then we'll also see what is STL, right? And then we'll see every container and associated containers, sequence containers, and we'll to come, right? So first, before we proceed, we'll just take a look at what is kind of STL, right? So STL is basically standard template library. So that is the full form. So standard template library, right? So it's very simple. So it is basically like a library. So which has nothing to do with the C++ language itself. Okay, so to give you a better analogy, so take English, right? And Shakespeare is an author. So this author has several plays and stories, and these several plays and stories just revolve around an idea which is portrayed or which is communicated, which is said to you through a language called English, right? So English is just a medium of communication, and it has nothing to do with the story or the play itself, Shakespeare's play itself. Just like that, library is basically a concept which may include any concept which is just implemented in the C++ language, and it has nothing to do with the language itself, right? So the best example that I can give you as of now is a square root function, right? So if you take a square root function and then if you put give 4 to it, it will give you 2, right? It will also automatically return 2, right? So this square root is a mathematical concept which has nothing to do with C++. So this square root function can be implemented in Python or C++, right? You just need to know how to calculate. But when you write a program, you cannot go around and implement a square root function all by yourself every time you need a square root function, right? Also, you're not the best person to implement it, but to have a performant square root function which is optimized to the platform that you're writing. So the standard template library, this is standard template library. This is a library which contains all of these functions for you, so that you can just simply go ahead and use square root function or any other function that you want, right? So this in this lecture we'll take a deep dive into other standard template library features. And also a disclaimer is, since many people in the orientation said that we are very beginners, we are trying to keep it as possible as beginner friendly as possible. Okay, so if you feel that it is too basic, and if you need more in-depth knowledge in that, you can just specify that. If you have extra time in the at the last part, I'll just explain how it works, right? So is it fine? We want you to explain, bro. Okay, which one you want me to explain? Loops and functions. Do you want me to explain loops and functions? Shashank Pavani. I'll just wait for 30 seconds so that the stream delay is compensated for that. We don't know. Okay, so you don't know loops and functions, right? So I'll give you a basic brief look at it. So when you need to know for and while loop. Okay, that's two loops that you need to know. So these two are really basic loops. So first we'll take a look at for loop. So the syntax for for loop goes something like this. Okay, so this basically means you repeat something for n times. Okay, for n times. So if you want to repeat something for n times, you use a for loop. Okay, it basically means that you know how many times the loop should be run. So it basically means I might definitely know that I need to run a loop for 10 times, right? So what do you run in the loop is basically what you want to do something. Okay, so let us like a basic take example, like if your house has 3 rooms, so you need to clean 3 rooms, right? So you basically know 3 times, so you need to perform the cleaning operations 3 times. So give me a second. So I'm back. So I'll just make it big. Okay, so I hope this is visible now. Yeah, so you basically use for loop when you know how many number of times you basically need to run the loop. So if you have 3 rooms in your house and you want to clean 3 rooms, you're basically repeating the cleaning task for 3 times, and you know 3 beforehandedly, right? So that's exactly why you use a for loop. And you use while loop in general cases where you run the loop while true, right? So while the state while something is true, while the statement is true, you do it until the statement is true. Like if the statement becomes false, you don't have to do that, right? So if you don't know the number of times you will be performing an operation in a repetitive manner, you can use a while loop, right? The basic syntax, I'll explain the basic syntax in C++. So the first thing here is where you declare something known as induction variable. This induction variable is not a standard part, it is used by the programmers for their convenience. So what you basically do is you will declare a variable like this, right? So you use this variable, right? This you use this I variable to as a loop variable, right? So if this okay, so I'll take another example. So if you want to run this loop for 5 times, let's take 5 times, right? So you have an operation called do some operation. Okay, so do some operation. So you have this do some operation, you have to do this 5 times, so into 5, right? So you take this variable 5 and then you assign this variable 0, right? So after doing it one time, you make this variable as 1, I equals 1. So you do that till 5 times. 4, 3, I'll make it 2, 3 and 4, right? So as long as this variable, okay, satisfies a certain condition, which will write here. Okay, the condition will be here, this is where the condition will be. So this, as long as this condition is true, this loop will run. So we'll basically write I less than 5, I less than 5. So this basically means I equals 0, right? I is less than 5, so 0 is less than 5. We'll check that 0 is less than 5. If that's true, then this operation will be executed. And then we'll take and then we'll write this here in this place. We'll write I plus plus. Okay, so plus plus. So this basically means increment I by 1. So if I is 5, I is 5, and then you do plus plus I or I plus plus, this will basically make this I to be 6, right? This is basically incrementing by 1. That's it, you don't have to worry much about that. This is the basic syntax that we always use that. So if you want to run the loop for 5 times, right, so you basically start with 0 and then you I less than 5, right? So you can also type I less than or equal to 4. I'll explain why. but since we don't have time, we'll just move fast. Okay, so also after that we increment this thing. So this basically, right, so you declare a variable here, and then before proceeding you check whether the condition is true or false. If it is true, you proceed. After completing this operation for one time, right, this will do the operation one time only, right? So one time. After doing that, this will be executed, which will increment the value of 5, and then we do the check, do the operation, increment, do the increment, do the check, do the operation, increment, do the check, do the operation, increment, right? So basically that's it. So you declare I int I is equal to 1, say I equal to 0. So I is 0 is less than 5 is true, so do the operation, increment, so it will become 1. You will do that till 4, right? So I is 4 now, 4 is less than 5, do the operation, and then you increment, I becomes 5. So 5 is not less than 5, 5 is equal to 5, right? 5 is not less than 5, so basically this loop will stop. And if you actually see that I equals 0, 1, 2, 3, 4 and 5, this is the fifth time, right? Fifth time, sorry, yeah, fifth time. So the loop will run for 5 times. In computer science and programming in general, you basically start with 0. So you start with 0 based indexing, right? We call it 0 based indexing, right? So this is how you do a for loop. So you declare a variable here, you do the check condition, you do the increment, right? So whatever variable you declare here will be available only in this scope. A scope is basically this is within this brackets. So you cannot use this I after this. So if you use this I after this, it will be an error, because this I only has meaning inside this part. Okay, so this comes under the programming fundamentals, so I can dive into it, the scopes of it. So I'll just leave it for now. Just take note of this syntax, it will be helpful for you. And we'll quickly move to while loop. So while writing a while loop, you use the same syntax. Okay, so while true, so as long as we have a statement here, so as long as this statement is true, you do some operation over here, right? So do some operation over here. So you can basically do something like as long as some variable equals okay, less than 5. So as long as this variable is less than 5, you can do the operation, right? This basically means you need not increment this variable by 1. Okay, so you need not increment this variable by 1. You can also do a plus 2, right? So this basically says that I don't know how many times a loop is going to run. So it may run for exactly 5 times or less than 5 times or more than 5 times even. So since I don't know the number of times this loop will be running, I'll use a while loop because I'm sensitive about the number of times. So you can basically do statement, right? So you can also have compound statement like and true, maybe like you want something like I less than 5, something like that. So you can do that. Okay, so yeah, that's it. So since we are doing now you got a pretty good idea of what for and while is, we'll go with the point. So since you know functions, okay, I'll teach functions after that, because functions is also a very big topic. So you leave it that first. As for now, we'll take a look at const t ampersand. Okay, before that we'll complete the explanation that I started for STL. So STL is basically a standard template library where C++ standard is standard, right? So there's something known as ISO CPP, and this is an international standardization organization that is for dedicated for C++, which standardizes and maintains the C++ features. What should be in C++, what should not be in C++. We call it the standard, right? So this standard will defining the rules of C++, also defines a set of template functions in and a library which is basically known as a standard template library, and this is the library, right? So we'll be using this library. There are so many containers and functions in this library. So this will be very useful for us in CP, and we'll not be taking a look at every container and every function in that. We'll be taking a look at all those things that are actually useful for us, right? So that's basically library. And if you want to know more about libraries, you can basically look what a library is, right? So what a library is. So that's STL for you. So we'll go with what's const t ampersand, right? So when I have an unknown variable, let the unknown variable be x, right? So let the unknown variable be x, right? So this is an unknown variable. Similarly, we use t for the type. So let's consider that I'll take this and take x, right? So I have an integer x, right? So integer 2. So if I want to make this as double, I cannot write int, double, float every single time. So basically to teach in this manner, I'll just use t, right? T basically means type, any type that represents. So that is the t over here. So you can replace this t with int if you want, or double if you want, or float if you want, or bool if you or bool if you want, right? So I cannot go forward and specify every single constant ampersand and const double ampersand. So instead I'll just t, and this const basically means that it will be runtime constant. So why are we concerned about runtime constant? It's very important, and you'll see why as we move further. I'll give examples of why why this is a very important thing, and then take a look at references, right? So before reference, I'll take this. Okay, so I'll just make an example. So you have int, okay, I'll make it int 2, int x equals 2, right? So this reference basically means that you won't be copying a variable or the value from the variable. Instead you will take the variable as it is, right? And you're basically taking the underlying address. So that basically means what reference is. As for the exact definition of what a reference is, it's more into the C++, which basically means creating an alias or alias, whatever you call it, for a variable, right? So since we cannot spend more time on this, I'll basically give what it is, right? So when you have an int x, and then you do int x equals 3, right? You're changing the value of this variable, right? So I'll create another variable here, int x, and then I'll try to, right? I'll try to print this variable. So first we'll try printing it. So we have 2 here. Oh, so it's 2 here, and then I'll try to call this function. Okay, so this is I'm calling this function over here. So I've defined a function foo, name of function is foo, and it is getting one parameter, and I'm calling this function. Okay, so I'll try to compile now. Way too few arguments. Yeah, I'll just print x. So now it is 2 2, right? So I'm passing this variable 2, and then this variable 2 is not how it basically sent is you're basically copying the value of x, right? So what you're doing is you're taking this value 2, and then you make a copy of 2, and then you send this 2 over here, and then you redeclare this here. So this is what basically happening here. So instead of copying every single time, we don't have to copy. Instead we can just alter this variable. So that's exactly why we use an ampersand. So this basically means this variable is now reference, right? So this you'll have to in your first year you'll be learning about formal arguments, actual arguments, parameters, formal parameters, actual parameters, and then how a reference variable works. And this reference is basically creating another name, right? So let's consider that your name is x, your official name is x. So people call you x in college, right? But in your house, people don't necessarily have to call you x, right? So they have a pet name like Chinnu or whatever it is. So this is basically creating another name. So when you have a reference, you are basically creating another name for this variable x, right? You can also do something like int ampersand y equals x, and when you do this, y is not x is not copied into y. Instead y is basically another name for x. So if you actually it basically means that there is no memory allocated for x. So this entire thing, this entire program, if you take, there's only memory allocation for x. I'll remove this. So there's only one memory allocation, that's for x, and y is not a variable at all. Y does not occupy memory. Y is basically another name for x. So when you change the value of y, you're basically changing the value of x. And to prove that, I'll just uncomment it, and then I think I'm changing the value. Okay, so as you can see there, I'm changing the value of y, but it is being reflected on x. It's because y is basically another name for x. So what I'm doing is basically referencing this variable. So that's what we call as a reference, right? So this is what we call as reference. Now why this reference is very important is basically you cannot copy every single variable. So let's consider that you have an array, right? So array. So let's consider that you have 1000 elements, 1000 variables, right? So you cannot copy this 10,000 variables every single time. You need to call this function. So instead you can basically reference this, and then you can pass it, so that you're basically changing this variable, but you're not making copy. Remember that copying things in C++ or any language is basically very expensive. So try to avoid a copy. So for us to try to avoid a copy, we basically use a reference. And I'm teaching this topic, taking some time to teach this topic only because of this is not available in C. Okay, in C you have to use pointers. So since I don't have to teach you about pointers and stuff now, I am teaching you what is reference, right? So if you have any doubts with this function parameter passing, you can basically think it like this. So if you have a parameter like this, and then you're trying to pass a parameter, right? So I'll change it foo of some value 5. Okay, so if you're passing, try to pass this value this to this function, you if you're confused with it, what you basically do is you go to this function and then type equal to 5, right? If I pass some variable here, and then what you do is type equal to and then you type variable. This is exactly what is going to happen in this function before this function is going to be executed, right? So if you are confused, you can use this technique. Okay, that's the basic thing. So if you take this reference over here and then you try the same thing, as you can clearly see that the value of variable is copied into x, and if you add an ampersand over here, this it is not copied, right? So you cannot write this in the code, but you can check this if you want, if you're confused and if you're starting now, right? So that is a reference. So since we looked at what a const is and what a reference is, now we'll look what const t ampersand is, right? So const t ampersand is basically a constant reference to a variable. This basically means that it can bind to L values and R values, both L values and R values. You can also bind to PR values, right? So we'll not go in depth with what L values, DL values, PR values, X values are as of now, but I'll just basically say that if you have int ampersand x over here, it's basically a reference, right? You can only take a reference to another existing variable, which is x is equals 2, and you cannot do for 2. If you pass in 2 is not a variable, right? 2 is a numerical constant, which is 2 is basically number, right? So you cannot pass 2 to this function. So I'll try to compile it. It will give you an error. Cannot bind a non-const L value reference to type int ampersand. It is basically because 2 is not an existing variable. It is instead a number, right? So we call it a literal. So or PR value and R value, whatever you want, you can call it. So because PR value is subset of R value. So if you pass x instead, this program will run, right? So in order for us to pass both x and then 2, right, as a number, this is now a limitation, right? So we have to you have to overload this function, right? So we don't have to do that. That's exactly why we'll always use const. So what basically means that in C++ rules, you have this rule where we say that if something is a const int ampersand, it basically means that it can bind with also with R values. Why? It basically means that this 2 is not going to change, right? As you can see, this 990 milliseconds, which basically means the program is compiled and there is no error, right? It's because of this const. Why? So when you pass a 2 over here, it goes like this, right? So this 2 is a numerical value which may never change. It's a constant, right? And we also promise to the compiler that this is a constant. So then this is a constant and this is a constant value which can never change. This can bind to this variable x, and you can also pass in a x, no problem, no issue. So I'll just duplicate this and then run this, right? So as you can see, this will run. But if I remove the const, this won't be running. There will be an error. It's because this 2 is cannot bind a non-const value reference. It's because 2 is a number and it's const, and this is not possible. So if you take int ampersand 2, which basically means that this x can change, right? So we are not promising that this x won't change. So we should make a promise that this 2 change. So this is what we call as const correctness. We don't have to look into this const corrections as of now. So but yeah, so this means we won't be changing the value of x. So you can now pass a 2 value. So now we saw what is STL. So we now saw what is t ampersand, const t ampersand. We always use const t ampersand everywhere, right? So to avoid a copy. So if you avoid a copy, you basically have a very big performance improvement over anything. Now I'll give a 1 minute break, just 1 minute break. Just post your doubts if you have any. It's already 25 minutes. So similar to type def kind of thing. No, it's not similar to type def. I'm just saying instead of I don't want to waste time typing int and double every single time, so I basically prefer 80, right? So just 1 minute. So yeah, 1 minute. Ask any doubts if you have so. Don't worry if you don't understand this. We can also discuss this in our Discord channel after this if you don't understand, right? So we'll also provide resources at the end of this session. At the end of the session, I'll be giving you a complete Google document where it contains all the resources. You can also check that, right? So if you have any doubts, so I guess you guys don't have any doubts. Okay, T should be defined before. Yeah, T actually should be defined before, but I don't since for the teaching purposes I'm basically taking T as a convenience, right? So T is just a convenience, it's not part of the language. Don't confuse this T to the language itself. It is just for my convenience that I'm saying that I'll use T wherever I want to use a type, right? So I'll just change this. Instead of writing int over here, I'll just type T. So you guys should understand that any type. So at first we'll go with the first container, and we'll look at static arrays, right? So in C++, we'll go apart from C++ and just look what an array is, right? So let's consider that you have a student database to manage, and then you have to uh, store the details of students of a college, right? So you do t student 1 equals details, right? So now you can show the details of one student, and to show the second student you have to do this, right? So I cannot create 1000 variables like this, right? If there are 5000 students in a college, I cannot create 5000 variables where I have to name student 2, student 3, right? So instead I'll use a data structure known as array. So array is basically convenience. So array is basically a contiguous, I'll go to this, I hope this is visible. So array is basically a contiguous allocation like this, right? So this thing, elements in this array are actually contiguous. Contiguous means after one another, right? So the first element will be here, second element will be here, third element will be here. So this will basically allow us to store how many number of variables at the same time, right? So let us consider that I'll have to store 50 variables. So I'll take int array 50, right? So this basically means the name of the variable is array, and this variable is an array. It stores 50 variables of type int, right? So this is a basic syntax, and this is known as, we call it C style array. This is a syntax to declare a C style array, right? So I'll use words define, declare, and initialize interchangeably, but they are not the same. Okay, so you don't have to worry about that. So I'm basically declaring and defining a C style array uh, of type int and 50 elements, right? 50 elements. So this is a C style array, right? Now we are looking at C++, but so we don't have to do with C style arrays, right? So most of the time C style arrays decays into a pointer, and then it'll create a lot of problems. You have to deal with pointers and stuff, so you don't have to deal with all the stuff, right? So C++, the standard template library which we talked about before, also provides us a container called a C++ array, a simple array, which is basically an array that you can use, right? So it is implemented for you by the C++ standard itself, right? So before going to that, I'll just look at what is static array and dynamic array. I'm taking it as slow as possible, so even if it takes a lot of time, it's because for you people to understand it. Okay, so let's ignore what static from C++ as of now, right? When you go inside C++, static has a lot of meanings, but let's not go into that. Let's come out of C++ and then just look at a general concept of what a static array is, right? So this is a static array. So when you say that this is a static array, you mean that you can only store 50 elements, right? So this is the 50th element, right? So this is the first element. And if you use all these 50 elements, like if you show some values 3, 7, 8, 3, 7, 8, 9, and then 9, and then the last elements go something like 4, right? So if you use 50 elements, and then the array is full now, right? So I'll basically remove this. Yeah, okay, it's fine now. So now this array is full, right? So you cannot store any more elements in that, and there's no chance for you to increment or increase or do some more memory allocation at the end so that you can store 52 elements. No, you cannot do that. That's what is basically known as static array. So when you are done with this 50 elements, you are basically done with that. So you cannot increase or decrease this, right? So you cannot increase or shrink the size of this array. You are stuck with 50 elements for forever. So either you should delete this entire array and then create a new array, or you have to create another array where you say int bigger array of 100 elements. So this, we are creating a bigger array, and then we'll copy all the elements from this array to this array, right? So that's what a static array is. So if you run out of that, you'll also create another bigger array of 200 elements. So this is a cumbersome process, right? So we cannot create a very big array. And the problem is basically, so when you don't know how many elements you're going to deal with, right? So when you provide a software to a college or any problem, you have no idea of how many elements you'll be dealing with. You can deal with 10 to the power 6 elements, 10 to the power 5 elements, 10 to the power 4 elements. So you cannot beforehandedly guess that. So most people what they do is basically declare very large array. So this is basically, I think this is 10 power 7, right? So we are allocating a static array of size 10 power 7 of type int, 10 power 7 elements of type int, right? So this is basically a waste of storage. So when you store only like 5000, right? So when you store 5000, rest all this array is basically memory hog. So you're basically wasting memory. So that's exactly where dynamic arrays come in this picture, right? So when you have a dynamic array, so you take this as I'm trying my best to draw. It's very hard with the mouse. So let's consider that you have 10 elements, right? And then you store elements like this, some elements, right? So some elements, and when this array is over, you can basically add more elements to this. Okay, don't ask me like what's the difference between this dynamic array and linked list, because linked list is also something like this, but linked list use completely a pointers. It's not a contiguous storage operation, right? So in this array we can promise that this element is going to be a neighbor to this element, right? In memory, I mean natural memory. So this is contiguous, like every elements are continuous in the memory, like memory location. So if you want to access the fifth element, you can basically start from the first, and then you can go 4 times, and then you'll reach the fifth element, right? So that's now we know what an array is. We'll take a look into dynamic array. So we'll have this dynamic array. So when you run out of elements, you can basically increase that. That's a dynamic array, right? So as for how this is implemented in C++, it's part out of our scope. Okay, even in C++, we actually see a dynamic array is basically like reallocating that. Like if you run out of 50 elements, inside C++, they'll not show you how the implementation will be there. So they'll basically allocate another array of size 100, and then they'll copy all the elements. Like that's how dynamic array in C++ works, but there's no other way, right? So but anyways, if you go out of C++, this is the difference between static and dynamic array. So now let's see. Now we saw C style array, right? So we'll see how we do it class C style array. So I'll basically need to include a header for that. It's known as array, right? And then okay, I'll delete this. I'll keep it for now. I'll keep it for now. Okay, so in order for us to declare a C++ style array, I have to use std. Okay, I'll type t over here, and then right, and name of the variable name. Okay, so this is enough. So this basically means the std is a namespace, right? So as for what namespace is, you can basically Google that. What is namespace? That will give you the answer, right? Because I cannot jump into namespace now, so it will give a, like a very big it will take so much time. So the long story short is basically when you have variable x, right? I have x, and then if you want to have another x, right? So you cannot have another x because this will be in a name collision. So there are two variables with the same name, right? So you cannot have this. So to prevent name conflicts, right? So the best example that I can give you is in a class there will be two Ramesh or two Suresh. You can take an example, right? So in order for them to differentiate, we basically use initial. So one guy will be R Ramesh, and then another guy will be maybe S Ramesh. I don't know. Okay, so some Ramesh. So we differentiate with the base of with this initial, right? So this namespace is basically to resolve name conflicts, right? So to get an in-depth look, you can basically look at any reference or documentation. So this std is a namespace that is defined by the standard, so that every standard function and container goes inside this, right? So if this basically means that there will be no name conflicts, even though if you have another array, right? So if you have your own type, a user defined type array, this will not be a conflict with this array, right? So this user array is different from std array because this std array is provided by the standard. So we don't have to go and get an in-depth look in that. So this is a namespace, and then this is scope resolution operator. This basically say that fetch the array from this namespace, right? So it's basically like initial and name, right? So this is an operator, scope resolution operator, which will basically fetch this array from this namespace, and then this type t, where you put the type int, double, whatever type you want, t, and then this n is basically where you put the size 100 or 5 or whatever size, right? So 100, so we'll put in, and then after closing this angle bracket, we call it template bracket in C++. If you want, you can the general name is angle bracket. This is basically, these two are template parameters, right? So I cannot once again I cannot jump into template because C++ is a very vast language, and then I cannot cover each and every single topic as of now. So these two are template parameters, right? So the first template parameter is the type, we'll put int or something like that, and then the second one is 5, the size, and then you take the name of the array, ar, right? So this is how you declare an array. So now as we declared array, this array will have 5 elements, 1 2 3 4 5, yeah, 5 elements, and this is a static array, right? Static array. And now we'll go with the dynamic array. For that you need to include another vector called vector. Now we have to include this header file, so that we'll have this vector, right? So since vector is a dynamic array, you don't have to worry about the size, right? So if it run out of space, if it runs out of space, like if it goes 10 elements, it will automatically relocate itself and then to rearrange itself so to be a bigger array, so that it can store 20 elements, right? So you don't have to worry about the size of the array. So for that we'll use basically this rt wake. Okay, so this is how you declare a vector, where the t where you send only one template parameter to the class, and then that's basically the type. So put int, for example, take int, right? So here we declare two array, right? So I don't want to take a deep jump into how the constructor and the number of constructors for this thing. So the general rule of thumb is basically, if you want, you can leave it like this, or you can put something like you can put open and close space in this. This will basically default, like it will initialize every element in as 0, right? So 0 0 0 0, so it will initialize every element to 0 in the array. You can basically also put that in this also, but it doesn't make sense in both the cases. So to avoid any confusions or any advanced topic like going to constructor and how the constructor works, we'll skip that, right? So how do we put elements inside this array, right? So when you want to put an element inside a vector, what you have to do is you have to put wake, and then you have to call a member function, right? So you ask for what a member function is. You need to know how classes and functions works. So classes, objects, you'll also have to learn classes and objects for that. So I really hope that you know what member function is, but even if you don't know, you don't have to worry much about it. You can just think of it like sending something to this vector, right? So you emplace back. So this is a syntax to put element inside this vector. So this vector is basically the name, this name, and then this emplace back is basically saying that you want to put element in the back. So I'll just erase everything, then explain everything from scratch, right? So if you have an element 1 already in the vector, okay, so bear with my handwriting. So if you have a vector, and then if you call emplace back, this basically means of 5, right? 5. So we are trying to emplace back 5 in this vector. So this is the back position, right? So it will emplace 5 here, and then if you call emplace back once more and 2, now this is the back, you put 2 here, right? And there is a very confusing part over here, where usually people do something like this, right? So this is basically a square bracket. So this is how you access C-style array, right? So I'll also show you this analogy side by side comparison, so that you don't get confused. C array, and I will create 5 elements. So in order for you to use this array, and the first element, four, 3, 2, 1, right? So this will access the first element and then change the value. This will access second element and then change the value, third element, fourth element, and fifth element, and so on and so forth. You cannot do the same thing with dynamic array, which is a vector, right? That's a problem with that. So as for why, it depends on the implementation details, because a vector is not defined as you think, like as an array, but you can do the same with array, but you cannot do the same with vector, right? So if you want to put 5 elements inside this vector, you have to write a for loop, right? So this will basically emplace back 5 elements in the vector, and then the size of vector will become 5, right? So you cannot do something like this when you create the vector like this. So imagine, keep in mind that, don't forget this, when you create a vector like this, keep it side by side. So when you create a vector like this, you cannot insert elements like this. The only way for you to insert element is this. You can alternatively also use a function called pushback. you can use either function. You can either use simplest back or you can use pushback. The difference between these two functions is basically if you already have a variable, I is already existing variable, so you can basically push I. If you don't have an existing variable, like you're passing a variable like 2, you can use simplest back, right? This does not make any difference when you're dealing with integer, which is primitive types. This only makes a very big difference when you have a type, a very complex type, user defined complex type, which basically have a different destructor, different constructor, different copy constructor, stuff like that. Which is none of our point, is out of scope. We'll in CP, as far as CP is concerned, we'll basically using trivial types like int or double or any other trivial type, which is primitive types, right? So in primitive types, you can use any function interchangeably. You can either use simplest back or either use pushback, right? So I'll just stick with simplest back as of now. So now this so I'll write so when you want to push back elements, you have to push back in this way. But when you want to access an already pushed back element, you can do it this way, right? So I'll show it. So as for why is basically hard for me to explain as of now, because I'll have to work with how placement new actually works in C++. I'll not go into that. So I'll just show you how this works, and then where to use which, right? So which, if you have this scenario, you have to push back, and if you have another scenario, you have one more way, you have to resize the vector initially, and then you have to do that. So I'll just make it actually save. Yeah, so as you can see, I'm starting with I equals 0, and then I'm going looping for 5 times. So while looping, I'll push place back I, the value of I. So first I place back 0, and then I place back 1, and then I place back 2. Oh, sorry, coffee. I less than 5, right? Yeah. Yeah. Okay, so I have to in here. Okay, so this as you can see now, the program returns 139, right? So this basically means that you are messing up with the memory allocation somewhere. Why? It's basically because when you declare an array, you cannot do something like this. This is an illegal memory reference. So I think this will give you a warning if you add wall over here. Let it add wall. Okay, yeah. Okay, it does not warn you about that. Okay, now, so as you can see that when you declare a vector like this, you cannot use this, right? The only way for you to insert element inside that is to use simplest back. No other way. If you used to do something like that, this is written an error, right? So I'll remove that and then show you. Now as you can see, this program STL is compiling fine, running perfectly fine. So I'm trying to output. Okay, I hope you guys know how to do an output, right? So this is how this is std cout. This is also part of the using the namespace, standard namespace, and cout is basically console out, so where you write stuff to the console, right? So I hope this is very pretty simple. You can take care of it, take care of it after that. So you are accessing. So when you access an already existing element, you can use this square brackets. But the element, if the element does not exist already, and if you want to insert it as the first time, you have to use simplest back. This is not the same case with array, right? So I'm not talking much about array. It's because you'll never use, almost always never use a static array, which is as std array in C++ as far as CP is concerned. So not used for CP. So that's why I'm not going taking in-depth dive inside this static array. So but just you guys need to know that something like this exists, right? So I'll just say that this is how we declare an array, and then if you want, you can use it same like this, right? And I'll close it. Now when you declare an array, you insert elements using place back or pushback, whatever you want, whatever you comfortable you are, as long as using int, right? Only if there's a problem if you use more complex types. And then after inserting all the elements, you know that all the elements are here, right? So you can basically use this the square brackets to access all the elements. So this will basically access the ith element of make, and that's how you do that. And okay, now we'll see how to insert elements like this, right? Like this. So for that, you need to know something about vector. When you create a vector, right? So when you create a vector like this vector will look something like this. This will not have any memory in that. This will basically allocate memory, but you can basically do nothing with this. This is a empty memory. So I'm not going to take an in-depth dive in how placement new works, but I'll just explain that. Okay, I'll take an in-depth dive in that. You cannot do something like wake of zero, wake of zero is the first element, right? So zero based indexing, something like this. It is basically because there is no element in this vector as of now, right? So you can basically, if it has elements like this, you can basically, this is zeroth element, right? So this is zeroth element. So in order for you to access the zeroth element, this zeroth element should be allocated for you. As of now, there's no zeroth element allocated for you. That's exactly why you cannot use this, right? So let's quit that. Okay, so you need to know how to use this so that you do not have to use this place back function every single time, right? So I'll just basically deal with that now. What you do is, you know that wake dot, there's a function called resize, and if you call this resize function, this will basically allocate 100 elements for you. So what is basically doing is, when you have this vector, this vector is empty, right? So this is empty vector, and when you do this, it will have 100 elements, right? It will have 100 elements, and default some value, mostly 0, right? So this is what basically happens here. So mostly in CP, if you actually do, people will call the constructor of this vector like this. Okay, so I usually don't recommend this way of initializing a vector. This is a very bad way. So if you want, you can basically if you want n elements, you can take int n, and then you can take the input std cnn. Usually people do this in order for them to allocate n elements in n elements in an array. So you cannot do this with a static array. It is because in a static array, right, in a static array, you can never change the size of the array. So this n should be known at compile time. Okay, though there are two time realms, if you want, you can call it that, but the one is compile time and another one is runtime. As this is very obvious that you are getting input of n, right? So you can only get an input during the runtime. So for a static array, this is basically I compile this, you get an error. As you can see that the value of n is not usable in a constant expression. This basically means that int n is not a constant. This template, okay, this is template type parameters, it's a deduction, so we don't need to go with that. So this n is basically not a compile time constant. You can only have a compile time constant. Size of the array, a static array, should be compile time constant. Only then, when the program starts its execution, will be allocated for you, right? That's exactly why you will never use an std array in CP. So you don't have to worry about that. So what people usually do is, they declare variable n, they get the input, and then they declare a vector of size n. This is not usually recommended. What you can do is, instead you can basically do this one, resize of n. You can basically do this every time, right? So both are the same thing. Calling the constructor and then with the n is exactly the same as resizing to it n, right? So you prefer, you can do anything you want. The thing is, when you do this, now this array will, now this vector will become a c stat, will become similar to c static array, right? So now you can do vector of 0 equals 1. So instead of doing that, I'll just do vector of I, right? So equal to I. I'll do this, and I'll take this. Okay, now it is returning 135. It's because, so vector of I equals, I'm taking, okay, I'm not giving input, right? So where do I give the input? I'll give it press 5. Yeah, so as you can see, I'm giving input as 5 and then it is running perfectly fine. Now, since you are resizing it, so what is mean basically means resize is basically you're allocating 5 elements, right? So before you go, that's it mostly about array. So we'll also look at some of the some of the member functions of array. Before that, I'll give 5 minutes time. So if you want, you can ask any doubts. I know I'm taking it very slow. It's because most people said that we are very beginners. So I'll just make it as beginner friendly as possible, right? So as of now, we'll take a look at what iterators now, iterators, and then we'll also look at some member functions. Okay, so after this point, after this, every other container that comes after this vector will take only less time for me to explain, because as you guys already know how iterators works and how member functions work and how most of the containers will work, right? So if you guys any doubt, I'll just clear it now. Any doubts? I'll just make the break short, like 30 seconds. Okay, I guess I'll take it that there are no doubts. So we'll move to the point where we discuss about iterators and other member functions. Okay, so there are many member functions. I'll take a look at it. So we'll basically, okay, right. So when you before that, I'll show you something. I'll try to, okay, now this is a member function. This member function will return the size of the number of elements that are currently being used by the vector, right? So I'll duplicate this and then I don't think I need this. Yeah, I don't need this. Yeah, I can paste now. So as you can clearly see that the first time when you execute vector size, it is 0, right? So the size of this vector is 0. That's exactly why you cannot do something like this. So how can you insert or change the value of change the value of particular element in an array when it has 0 elements, right? It has 0 elements at the first, but after resizing, if you check the size, it is 5, right? So that's exactly why you have to either resize and then use it, right? Or you cannot use it. So it's running now, it is because due to some other thing. So just quit it now and we'll completely remove this, and if you check that, will become 0, right? So if you do a place back, lsm 5, I'll just do vector pushback as of now, right? So I'll push back and then I'll get the size over here and then do some editing. Yeah, okay. So as you can see that before starting the loop, the size is 0, right? So if you want clear formatting, I'll just make it clear, right? So before starting, the size is 0. After pushing back one element, the size is 1. After pushing back two elements, the size is 2. And after pushing back 5 elements, the size is 5, right? So you can see that when you push back one element, the size increases by 1. So that's exactly why you have to either use pushback or resize the vector and then use it like a C-style array. So if you want to use it like this, you can use it like this. If you want to use it like C-style array, you can use it, you can resize. So as of Y, so when you know that you'll be getting n inputs directly from the user, you can basically use pushback. So you can basically create a variable called input, right? And then you can get input and then use that, right? So I'll give this example at the end, right? So I'll give one example at the end. So basically get input from the user and then you push back this input and then you'll go forward with it. But if you want this n elements to be allocated beforehandedly, like for example, if you want to do something else with that array, so you can use resize, so that you will have all the elements beforehandedly, and then you can use any element. It's like if you use a fifth element, you can use sixth element. But in this case, you have to go one by one: first element, second element, third element, fourth element, and then you have to go one by one. In that case, you don't have to, right? So just check the question. If the question gives sequential input for you to put it in an array, you can use pushback. If the question demands you to use something else, like if it does not give you sequential input, if it gives you input in some other order and you have to input in some other way, so you can use it, you can use vector that this way. I mean, you call the constructor, or you can basically resize that vector and then use it. Both are the same things, right? So now we saw vectors. We'll take a look at iterators, right? So iterator basically a type, right? It's basically a class, a template class, group of template class. There are 6 iterators. There are actually 5 iterators, and there are 6 iterators from the latest standard CPP. So that's as far CP is concerned, C++ is concerned. As for CP, you need not worry much about iterators. Okay, so iterator basically think of it like an pointer to an element in C++ container, right? Container. So we have this over here, right? So I also have Visual Studio Code by my side. I'll also show you some examples of how it works after this, right? So we have this element here. So this is the first 0th element, and this is the first element, and this is the second element. This is the 100th element. So imagine you have a pointer, right? So you have a pointer. Pointer is basically a variable which stores address. Okay, so in this memory, in memory location, this will have an address like basically a 0x, some random hexadecimal, right? So this pointer variable will store this address, right? So imagine, okay, iterator is not a pointer, okay? You have to be sure of that. Iterator resembles or is similar to a C-style pointer, right? So basically like having a pointer to each and every element. You don't have a pointer to each and every element. You have only one pointer. You'll move this pointer. You can make this pointer point in this place, and then once you use this element, you can go to the next element, right? That's the part that will be enough for CP, right? So as always, we'll also give a document where we'll have in-depth look in how iterators work, what is iterator. So you can check in the doc. It's because we're on time constraints, right? It's already 5 p.m. now, so I don't know how many people are actually watching. So some people might get bored because of me teaching very slowly, but please bear with me because many people are there who are very new to programming. As you can see, most of the people didn't even understand how a loop work, right? So I have to be very slow with that. So a pointer is basically a variable which stores the address, right? So it's basically like pointing. So let us consider that your house, right? So your house has address. So I can store your address in my house also. So whenever something comes to my house, I can basically check that address, and then I can send the parcel to your house. That's how pointer basically works. Pointer basically stores the address, and in C++, iterator is basically a class which also comes under this standard template library. That's an iterator library specifically for that, which resembles a C-style pointer, right? So before we go into that, we'll also check say one more thing. This vector is a dynamic array, right? So dynamic contiguous array, I believe. Contiguous array, and std array. You saw the std array, right? So std array is a static array. Static contiguous array, right? So these two are known as sequential containers, right? A container is basically it is not a library. So we do have a container library, a very big container library, and this vector array, and every container is part of that container library, and it is divided into subcategories. And the first category is sequential containers, where you store all the elements in a sequential manner, right? So container in basically in C++ in generally means that a container will basically allocate and then manage its own memory for all the elements. You don't have to worry about the memory management or anything with that. The only thing that you go is like a plug and play, or basically a good to go thing. So you basically use that for your users, right? So you don't have to worry about the memory management underlying principles of that. So if you take a C-style array, as I said, if you run out of 50 elements, you will have to allocate a new array of size 100, and then you have to copy all the 50 elements, right? So in C++ style standard template library, you don't have to worry about that. They're saying that you just worry about the part where you solve the problem. We'll give you all this. So a container basically manages its own memory, allocation for the elements, and will manage everything for that. right? So these two comes under will be under sequential containers. Okay, so next we have associative containers, which will be seeing in the point. So before that, I'll just teach you what iterators are, right? So these are iterators, right? So I'll start with this point by explaining. Okay, so you have an array here. So whenever I say an array, it basically mean vector, right? It's because you'll never use this std array in CP, because it's a static array, we don't need that. You guys, I think you guys are familiar with the size, and now you can take the input, how to take input, something like that. If you want to do that, you can basically do vector tree size of 5, so that you don't have to push back every time. You can basically do this I equals input, right? So this bracket is not a concern, so you can remove that. So you can also do this, right? So now let's take a look at iterators. So iterators are basically pointers, as I said. So now we'll take a look at how iterator basically works. So this is member function specifically, which returns an iterator, right? So when I say function, you have to be very much worried about what it returns after this point, right? So when you take this size function, okay, I'll switch the window so that it'll be easy for you. Can you guys see this? Yeah, I hope you now can see this. So I'm using this as a tool to so that I can show you everything. So I'll just increase the size. Yeah, okay. So don't need the same. So I have a let's take a function over here. Okay, so take a function, and I call it, okay. So if I hover my mouse cursor over this function, this will say what it returns, right? So now let's see for return. I have this many vectors as this many libraries as for my use, so that I don't have to write every single time. So I'll just include a vector over here, and then I'll use a vector over here. Okay, so I'll just, I hope this is visible for you. I use right. So now as you can see that this color notifies that this is a variable, right? So as you can see, this is a variable, and then this is a function. As you can see that this size is in color of yellow, right? So this basically means in my editor, it means that it's a function. So that's how I set the color theme. So if I hover over this, as you can see, there's a very big prototype of this function. So you can actually ignore most of the thing, and I'll copy this and paste it here. So as you can see that this is the name of the function. Okay, this belongs to the namespace std namespace, and this belongs to this class, and then this is the name of this function. So that's how you write this function, and then this function returns something known as size t. Size t is basically a unsigned integer, unsigned long integer, right? So it basically means uh, size t is basically equal to unsigned 64-bit integer in most of the places, right? But in ASCII standard, it basically means 64-bit integer, unsigned 64-bit integer. So now this size function returns as a size t, right? So from this point, you have to be worried about what the function actually returns. So when we have this function called begin, oh, we also have a friend function here. We also have this function, which will basically return the first element of your vector. As you can see, this returns an integer. Why this returns an integer? It's because we are creating with integer. So if we create this with double, and then if I change it, you can see that, come on, yeah, you can see that it returns a double, right? It is because friend returns the first element, and then similarly back returns the last element, right? So to access any element, we'll use this member access object, right? So member access operator. So now this is an operator. You can also check the return type. This returns a double, right? This returns a double. If I change it to int, I will change to int, right? So that's not the point. We also have one more function called add. This is basically this function. So these two are the same thing. The only difference is here, before accessing this element, the function will make sure that this element actually exists. Okay, if that element does not exist, it will give you an error. In this case, it will not happen, right? This is very dangerous. This is pretty safe. It's moderately safe, right? So here bounds checking are performed. Here bounds checking isn't done, right? So it's not done. So that's a basic difference. So it will give you an error if you're trying to access an illegal element. Like for example, your vector has five elements, right? Sorry. So I'll just yeah. Yeah, I'm sorry. So you have five elements. So if you try to access the sixth element, so since we're talking about zero-based indexing, 5 means the sixth element. If you try to access the sixth element with this member function, this will give you an error. But in this case, it won't give you an error, right? This will try to access whatever it is, and this is known as UB, undefined behavior. So you cannot define the behavior of what actually happens in this case. You can do anything, right? You can trigger a nuke, it can do whatever it wants, right? So this goes to undefined behavior. This does not. This will give you an error because there's a bounds checking. It will check that this 5 is less than this number of elements, so you can whether you can access or not, right? So before we go to iterators, I'll just go to iterators. So this function called begin. Now this function begin will return an iterator to the pointing to the first element of the vector, right? So I'll just show you the return type. As you can see that this returns an iterator or iterator for std vector specifically for our class, right? So this returns iterator. Now before we go to that, I'll just show you. Wait a second, I'll change the window. Yeah. So yes. So let us take this array, right? So we have a pointer, right? We have a pointer p, and this pointer points to the first element. This is the first element, right? So remember this is basically like a pointer, right? So but we'll call it as iterator, right? So I don't want you to confuse much by saying the technical details, so I'll just make it simple. So this begin function, I'll take everything. Right, so this begin function will return an iterator pointing the first element, right? So similar to begin, you have end, you also have end, and this is somewhat tricky. This is why most people get confused. This returns an iterator pointing to the element that is one after the last element. So this basically means that this is the last element, right? So now this is the last element, and this end function will return an iterator which is basically a pointer pointing to the element which is after the last element, right? So I'll also give you a documentation if you want. So I think it will be in Geeks for Geeks, right? So if you want, you can check that, I believe. I usually don't recommend you to check any of these two websites because it's not beginner friendly, but I'll just show you the definition of that. As you can see the image over here, the begin returns the first point to the first element. This is past the last element. As you can see, there's no element like that. This is the last element. I'll zoom it. This is the last element, and the end points to the element that is after the last element, right? So there is actually no element over here, but end points to this element for us, so that we can differentiate between the last and the element after the last, right? So as for why, we'll look into that after that. So it's exactly like this. So now why do we need iterators? The thing is, every time when you deal with C style code, you can basically deal with numbers, like having array of 5, right? Array of 5, array of 7 or something like that. But in C++, we are in dire need to use something known as iterators because that's very safe, right? So in most of the time, you don't have to worry about more problems in like low-level memory management and stuff like that, right? And most of the functions in the standard template library will use an iterator. You can take any function like maybe sum function, right? So if you want to sum n elements, the basic that you do is basically int I equals 0, I less than vector size, right? Plus I. I know why I'm telling. So I'll just have a variable over here, temp, and then I'll do temp plus equal to vector. Okay, it's very simple. I'll just copy this. I think I already did resize that, so I'll just make it. I'll just check whether this program runs. Yeah, it runs. It is running one. So I'll also take this. I'll take this, and then I'll try to. Yeah, so it is running perfectly fine. So I'll just like. Okay, I don't know what's the problem here. We have a vector here. We're resizing it to 5. I'll take this. For some reason it's not working. I'll check it why. So say because I don't think what the problem is. It's continuing one. If you want, I'll check the error. Okay, so I don't know what's the problem over here. So I'll just check it after that. So maybe we'll try it some other time because I was looking the first time we'll have integer 0 and 5. So 6, 8. So, yeah, I don't know why. So every single time the baseline is every single time you deal with a C++ style container, you cannot do this access like a C style thing. So we need something special for that is more dedicated with more C++ style, right? So that's exactly why we have iterators as of now. So when we're dealing with C++ style standard template library functions, most of the functions does deal with iterators, right? So when you have to do something like iterate from begin to web.end, right? So my hands are completely tied over here because I cannot go inside and explain what iterator is, how iterator actually looks like, how a vector class looks like, how the begin of this is going to be iterated to over all the elements, and how it will be implemented, how a legacy random iterator works, right? So I'll just keep it very simple as of now. So you will say that to C++ function library function iterate from begin to end, right? So I'll just I don't know why there's a problem with this function, but yeah, we actually went to bed. I'll just make it this. So I've initially 6 times. We have pushback, we are pushing back 8, and then we are trying to access all the 6 elements, right? So they should have okay, we don't have int of time. Oh, still doesn't work. Okay, I don't know why, but I'll check this afterwards. But yeah, I'll check it afterwards. But so you can rewrite this exact loop. The main problem goes as is because we have seen integer over here, and this integer is a number, right? So we cannot say the fifth element like this. Instead, this iterator is a convenient thing. We'll use this as a pointer. So when I say this pointer over p, and then I increment this pointer by 5, p plus 5, right? So this will now point to this element. To access that, I'll basically use like a C style pointer. I'll just dereference that, and then I'll use this. This is the fifth element, right? So that's exactly why we use an iterator. The main reason for you to use iterator is basically because no one is actually stopping you to write code like this, but the problem is most of the C++ library functions does use an iterator, right? So without further ado, I'll just rewrite this entire loop, and I don't know what's wrong with this, but I'll go to Visual Studio Code and then write code over there. So we'll just give a basic example of how it works. So yeah, so now we are in Visual Studio Code as we thought. So yeah, we'll take one test case, then we'll have 5, then this 3, space 2, space 3. What is it? Yeah, so I will take I'll make it one. Oh, yeah, so it's for me. Now I'll let go. So I'll create a vector over here. Okay, for the time I'll remove this one. Okay, so I don't want to use curly braces and confuse you. So I'll also create another one for SI, and then I try to take input from that. So now I'm taking input of the size of the vector that we need. So So I'm sorry because if you hear the keyboard sound that when I type, so it's because I cannot do anything. I'm using laptop mic as of now. Pushback off. I'll have to declare a temporary variable over here. So yeah, I don't have to use U64 now. Oh, I can get another template, so I'll just get some. So now instead of writing int I equals 0 and then I less than vector size, right? So as you can clearly see that now you'll be able to use this function, right? So no one is stopping you from using this function. Okay, yeah, so now this is perfectly fine. So you start from 0 and then vector of size of vector is basically 3. This is the input file, right? So for the convenience for you guys to look this entire program in a single window, I've made it in this way. I have a function for that, so that it basically reads the input from this file and then writes the output to this file. So that's basically it. So you don't have to look at the console every time. So you can see the input here, this is the output here. So I'm running one test case. The size of the vector is 3, right? So input size, and then I'm taking this input, okay, input, and then I'm placing the input. So I'll take it. I don't know why it's not working, but I'll just make sure it works now. So by the way, quick performance tip: don't use this over here. Don't use double quotes. It's because you're printing only one character. You can use single quotes if you use just printing one character, right? So you should use double quotes if you print more than one character, right? You're printing string. When you use a single character, when you print a single character, use single quotes. It's because it's somewhat, it'll give a somewhat performance improvement, right? So you don't have to use double quotes over here. So that's why I'm using single quotes over here. So I'll run this. It's building, as you can see. Yeah, so now as you can see the output over here, right? So the output is 6. 1 plus 2 plus 3 is 6. Okay, so I don't know why it didn't work in previously in that mobile. So I mean the online compiler, but now it works here. So I have given one test case. The size of this is 3. Now this is 1 to 3, right? So this is perfectly fine, but you cannot expect every single function in the standard template library to work like this. So now we need to know how to write a function that is using iterators, right? So this is exactly where you learn about auto. Auto is basically automatic type detection, so you don't have to worry about what type it is, right? So you can just use auto on the left hand side and then write anything on the right, so that basically detect the type for it itself. So use auto. Okay, so iterator equals big dot begin. I'll just type it first, then it not equal to big dot end. So this is very important, and once after this point, it will be very easy for us to take a look at next container. So you don't have to worry about that, right? So if you don't understand this, don't worry about that, because I've also included a section in the documentation Google Doc where I explained this part. Okay, so basically this function is returning this vector begin is returning a iterator pointing to the first element, right? So it returns an iterator pointing to the first element, right? So you don't have to worry about this const expert and then this begin and there's no expect right? So it's because C++ keywords which are defined as in the library for us to make sure that there's nothing goes wrong. So you have auto, right? This basically means that you don't have to worry about the type. So even you can use auto over here, but you have to make sure that you provide a value, right? So this 0 is an int, so this sum will be deduced to int. So if I keep this, it will become int, right? So I don't have to worry about this type. So I don't have to worry about the type. I don't have to type this big type, right? So you don't have to type this thing every single time. It's not good, right? So you don't write this big type it. So instead you will basically use auto. Is very convenient. So this starts from begin, okay, and then it goes till end. It not equals end, right? So this will go, yeah, so this will go till the end. The incrementation is basically the same thing. Okay, so there's nothing changes here. To access the element, you basically access like a pointer. So star it, when you do star it, you're accessing the element. This it is an iterator, And when you dereference the iterator, the dereference operator, the interaction operator will give you the sum, right? So if I run this code now, we'll get the same output. As you can see, it's fine, the thing is building. It's built. So the answer is 6, the exact same answer. So if you're worried about, I'll change this to 4, and then I'll build now. As you can see that the answer is 7, right? So this is how you write a loop. This is how you write a loop with using iterators. Now, as you guys know, iterators. So this begin is a member function. Okay, this will return a return to the begin, and end will also use that. So this iterators will be there for every container after this you see, like so it will be there for array, it will be there for vector, and after this you'll be seeing associative containers. We'll also have iterators for that, right? So I think that's it for vector. So use yeah, I guess you guys know about how to declare a vector, how to resize a vector, how to use elements. So you can use anything that you want, sir. Okay, so after that, before we go to map, we'll just say a pair, and then we go to associative containers, right? So these are sequential containers for you, and we are done, right? So we'll go to associative containers. Before we go to associative containers, we'll take a look at what is pair, right? So for us to use pair, we have to include some library known as utility, right? So include utility, hash include utility, and then you can now use a pair, right? As the name suggests, pair is very simple. We're just using two variables, that's it. So a pair can store a pair of variables, a pair of elements, that's it. You can use an int and int, or you can use int and double also, right? So this is incredibly useful. If you want, you can write that for yourself, like you can create a struct over here, pair, and then int a, that's it. That's basically a pair, right? So but the same thing, I think I have to say. So this is exactly how a pair looks, right? So you can write this for yourself if you want. If you don't want, you can basically include this utility header and then use a pair, right? So after this, we'll not be looking everything in depth. I'll just make a quick look about how it works, and then we'll get done with it. So if you have more time, if you want more time, I'll just explain some more concepts on the end. So we need a pair, right? So when you have a pair, this is how we declare a pair, like name. This is a name and name. If you want to use the first element of the pair, you basically access the first dot first equals 1, name dot second equals 2. So this will access the first element, and this will second element, and this first and second is basically the second stored value, right? This is also named, and this is how it basically looks like. It doesn't matter. So this is a pair of type int and int. So this is basically very simply store two elements together, right? It's like storing a and b together. So if you want, you can use this pair. So before we move on to associative containers, you have to know this. Okay, now we'll move to associative containers, which has maps, unordered maps, and ordered maps, right? So there's something known as ordered maps. There's something known as map and ordered map. Now let's look at what the map is. Map is basically an associative container in where you actually store elements based on key values, not on the indexes. In sequential containers, we used keys. I'm sorry. In the sequential containers, we stored the values of all the thing in the container in a sequential manner, in a contiguous manner, right? In associative container, there is no guarantee that you'll be storing every elements next to each other, right? So the implementation defined details will be hidden from us. But the basic thing that you need to know is basically a map is basically a hash map, right? So if you go and type what is hash map, so hash map, you will get more details on that. So that's basically how you store key and key pair values in computing hash tables. Data structure implements associative array. After data type is the okay, yeah. So this a structure that can map key to values, right? So when you have something like a name list and then mark, right? Name and mark. So A gets 50 marks, B gets 60 marks. Here A and B are keys, and 50 and 60 are values, right? A and B should be unique, and 50 and 60 not be unique. So it can be 50 and 50 also. A and B can get the same marks, but there cannot be two A's or two B's, right? So that's basically an associative container. So if you want to get an in-depth look, you can also check the doc which will be providing for the end. So as we can see that you have two associative containers. It's a map and another map. For that, you'll be using hash into map, and we also have something as another map. Yeah, another map. So this map offers associative container, and this ordered map is also offers an associative container. The only difference between these two are this offers on an average constant time lookup. I'm sorry it's taking too long, it's because I have to explain everything. So constant time lookup on an average, but it is not guaranteed, right? So the worst case is linear time. Here it is logarithmic time. I mean, I'll take log time. Okay, so I don't know spelling as a problem, sorry. So yeah, so it's log time. So when you declare a map, you'll basically use STD, right? Map. You use two things, right? One is a key, and another one is the value, and then name. This sounds very familiar, right? So I'll just ignore this. It's a force of habit. So yeah, so this looks very familiar, right? So this map, one element of a map is basically a pair, right? So one element of an array is basically int, right? So that's how map works. Map stores a lot of pairs, and then these pairs are a key and the key and value pairs, right? So if you type std map in here, you can basically see that in the definition itself. So std map is sort of associative container that contains key value pairs, right? So as you can see the key value pairs. So this basically, okay, I'll just move this. Okay, so the uses of map we'll be seeing that in the further sessions, right? So after this we have so many algorithms, so many data structures in separate, and then when we will be solving problems with map, you will get to know the exact usage, right? So as of now, the best example that I can give is a student and then mark, the name of the student and mark. So this is key is unique, so I'll just type it parallelly. So map key type and then value type, right? Name of map. So the key type is int, which should be unique. The key should be unique because you cannot have pairs like 1, 2, and then you cannot have pairs like 1, 3, right? So these are not unique is because, as you can see, both has the same key value 1, 1, right? So you can see the both are same value 1, 1. So but only the values are different. The values can be unique or cannot be unique, but the key should be unique. So you cannot have something like this. So that's a map, and this map is basically sorted, right? So that's what you saw that in the CPP reference page. When you have a sorted map, it basically means that you can have a log time lookup or insertion. Everything is logarithm time. Insertion, lookup, and then deleting elements. Even everything is a log time, I believe. So in another map, it's not the case, right? So you want on an average constant time lookup, but sometimes you are okay to have linear time lookup. That's the worst case, right? So that's the difference between map and another map. So in order for you to declare a map, you have to declare it like this. In order for you to put elements inside the map, you basically use place 5, 6. So this place 5, 6 basically does an place so that you create one element inside the map, one element pair, and then in that pair the key is 5, the value is 6, right? So that's a map for you. So we can also have strings, right? So we'll look at strings in a second, but for that we'll just look at map. So map is sorted, right? So that we can even guarantee that if you have two pairs like this. So I'll create one more pair 7. This fifth key is sorted in a manner that comes before the 7, right? And this 7 is will always come another pair that is less than 7. Any value that is less than 7, this element will be after that, right? So this is how a map works, a normal map. In unordered map, you cannot guarantee that, right? In unordered map is just basically a hash map that is not sorted. There's no guarantee for that it will be sorted, but it will promise you that it will give a faster lookup time. In map, it will guarantee you that you have sorted, but it will not guarantee you that you have a faster lookup time, right? So that's the difference between map and unordered map. So as for the way you use the map and unordered map, where you use an array and not, you'll be seeing that in the further sessions, right? This session is only about covering every container as much as possible, so that you will have a better idea about how to use a container. That's it. So you have container express. So in this case, we can also use this operator, right? So I cannot talk much about this operators because yeah, so this will do, right? So when you want to emplace something inside the map, you use map.emplace and then use 5, 6. So this basically emplace an element where 5 is the key and 6 is the value. You can also alternatively do this. Okay, if there is an element, right, if there already exists an element, this will overwrite. So when you do something like 7, when you have already have a 5, right, when you do this again, this element will be overwritten and then this will go, this will be gone. Now you only have 7. This is same case is also there in unordered map, right? So in order for you to declare an unordered map, you will basically do this unordered map. So that's the basic difference between map and unordered map, right? So as for every other thing, this basically same. You can take map.size. Okay, you can also take map.empty. This map.empty will basically say that whether it is empty or not. If it returns 2, it means empty. If it returns false, it's not empty, right? So that's a difference. You can also you'll also have map.begin. As we saw that map.begin returns an iterator to the first element of the map. Okay, the first element of the map means that it's a pair, right? So when you do when you do auto id equals map.begin, in array, if you remember, to access the element we just use star it, right? Star it. But in this case we'll have to use it of first. Why? It's because in array or vector we had only one element, we had only one integer, right? But in this case we have two, integer comma integer, we have a pair, right? So in order for us to access the first element of the pair, you have to use first. In order to first use second element of the pair, you basically use second, right? So that's the difference. If you want to do it like this, you can also do that. So basically what it is, auto temp equals star of it, and this star of it will give you the actual pair, right? And now you can do temp.first, temp.first, temp.second. The difference is this iterator behaves like a pointer, right? So that's exactly why we are using this arrow operator. This arrow operator is used to access the member of a pointer, right? So this behaves like a pointer, so use arrow operator to access the elements. So this will access member of pointer, and this dot operator will access member of object, right? So this you'll be learning this in your semester. If you have doubts in that, you can also ask on Discord server, where we'll be giving an in-depth explanation of that, how this works. So member of object. So if you want to access a member of object, you use dot operator. This dot operator. This was member access operator, right? If you want to use a member of a pointer, as we already studied that iterator behaves like a pointer, but it's actually not a pointer, but it behaves like a pointer. It mimics the behavior of a pointer. So we can say that we use this operator. So if you want to use that, you use first, right? This first comes from a pair. You remember, right? So when you have a pair, and if you want to use the first element of pair, we use pair dot first, right? This pair dot first will access the first element. Similarly, this it arrow first will access the first element of the pair. If you do this is basically dereferencing that iterator, which gives the exact element, and then you can do the same thing. As you can see, this is both the same. Temp dot first and the pair dot first will access the member of object. Yeah, there'll be one B. Yeah. So now we know that this map and another map. So everything is very similar. As you can clearly see that this is exactly why we needed iterators. When you use an array, you can do something like this, right? You can do something like this. But in the same case of map, this will have a different behavior. This will not actually access the object for you. Instead, if there is an object, it will give you access. It will access the object for you. But if there does not exist any object like that, it will create the object for you, right? So this is why we get confused. Most people really get confused when they do something like this. This is exactly why when you use C++ style containers, you follow the rules that are dictated by them, right? So the the standard library has this, and the standard recommend you to use this function to create a pair. If you do this, then most certainly you will be creating an element which is not there, so that you'll get sometimes you may get confused about why about the undefined behavior that you're experiencing in the program, right? So I prefer that you don't use this. But if you want to access that element, you can basically use name of element. So if you want to access that, you can use this. You have no other way. But you have to be very careful that when you do something like this, you're trying to access an element from the map, and if the element does not exist, you will create that element and then you'll try to get an access for that. right? So this operator returns to a reference to an object, and it returns to reference to the same object that is created if it is not if it's not actually there, right? So I understand that it's pretty confusing, but as of now you can just worry with this emplacing to insert, and then you can just do this to access. There are other ways to access this also. You can see that in STL map. For you to access that, I'll just show you the example of that. As you can see that yeah, this access or accert or insert specified element. This add function will access this element with bound checking. So as we already talked about in the array cell, we had two functions, right? So we have had this option, and then we also had this option. Here bound checking are not performed in array, right? And here bound checking are performed. The same goes with the map, but the problem is in a map this will access, and then if it is not there it will give an error. In this case, if it is not there, it will create an element and then send you a reference to that, right? So that's the difference between this add and then in this square bracket, which is basically the member access operator. So as this is the problem with this thing, because when you follow that, you can use that, or you can use this one, right? But if you follow the rules of C++, everything will perfectly sync together, right? So when you use iterators, iterators will have an exact use case, right? So that's exactly why we recommend you to use this one. If you want, you can also use that if you exactly know what you're doing, but be sure that if you use that, it's kind of unsafe, and you might end up somewhere else, right? So wait a minute. So as of now, we completed associative containers and sequential containers. So do you have any doubts? I'll give a 2-minute break. So if you have any doubts or anything that you feel that I didn't explain properly, I'll just do it now. Just give me just type it in the chat. After this, we'll not be covering everything in the detail. So we have like only few more topics to cover. I believe we covered most of the topic that we actually need to do. So we'll have like 1 or 2 topics. So we have nothing to do with that, more than that. Do you have any doubts? Do you guys have any doubts? Any doubts? Just put. If you feel that I'm not explaining some topic properly, just mention that. I'll try to explain it in a much more detailed manner. Okay, so I guess there are no doubts. We'll go to the last part where we'll be discussing about some math library functions and some some algorithms, and then something on string. Okay, so we'll first take a look at string. So string is not an official it's not an official data type. There is no data type called string in C or C++, right? So we usually we actually use this something like this, right? So string. Now this is not a string. This is not an actual string. Okay, I'll just intend. Yeah, this is not an actual string. This is a type of const char pointer. Right? So this will be a const char pointer. Now this is how we use a string in C or C++. C and C++ does not have a type called string itself. So the standard template library also provides us a string library where you need to include string for that. Right? I'll remove everything. By the way, guys, if you have any doubt in this point, like I guess it will be very hard for you to take everything in 1 or 2 hours. But yeah, there's no other way, right? So you have to do something about it. But if you have any doubts, you can post in the Discord server. I'll be very free, also I'll be giving you a detailed explanation about how it actually works, right? So if you don't have time for that, you can also read the documentation which we will provide now. Okay, so don't worry. So I'll just take all this. Now for you to declare a string, you can basically do string. Yeah, that's it. So you have to get a string and you have to name it. That's basically it, right? So if you want to put something inside this, you do equals to put the name, and that's it. Yeah, as you can clearly see that this is how you use a string. And in string you also have string dot friend. This will return the first element of the string. So I'll just show you. I guess this will be interesting. So I think you don't have friend element over here, so I'll just basically do I'll try to do something else with this. Okay, for some reason this, I think it's a problem with this compiler, I don't know why, but yeah, I'll just show you this. Okay, as you can see that front access the first element, back access the last element. So you can also have this operator. So you're gonna have a string of 0, and then this will get you the access to the 0th element. You can also change that. Okay, yeah, I think I found the mistake. So just name. Yeah, I'm sorry because it's named not friend. Yeah, I'm really sorry because I'm confusing with the names over here. So I usually don't name my variables at name, so that's why I'm confusing. So yeah, so as you can see that name.friend is h, right? So name.friend is h, and name.back will be o, right? This does also capture space. So when you type a space over here, the space will be there. So as you can see, this is space. This blue indication is basically marking the space. So hello world d is a friend back one, and you can also access this by see h. So we can also access this by 5. If you take the fifth element, this is the sixth element. So space, and to seventh element hello, right? So if you want print everything, you can do this. So I think there's some problem with my coding, so okay, I'll just take it. I have begin over here, right? So we have name.begin and then you can name and name.end. This was I. Yeah. Yeah, so as you can see that you can also do that. So this string is specialized. Take this as a specialized array, so that you can only store these characters, right? And this have some more functions, some more functionality, so that you can use that. So that's basically what a string is. There's nothing more that you need to know. That there are some other functions where will be useful for you. So let's name.find, right? So name.find, if you want to find an edge over here, this will return. So now this function will return an iterator, right? So this is exactly why you need to know things about iterator, right? I guess let's return iterator. Oh, I think it does not return an iterator. I think it returns some value. Okay, so right, so as you can see that I'll just make it just yeah. Yeah, so this does not return iterator. I'm sorry for that, but it does return something else as npos, which if it doesn't find the element, right? So if it send in a single character w, this will find the element for you and then return the index of that. So w is in the sixth index, I believe. 0 1 2 3 4 5 6, right? So w is the sixth letter in terms of zero based indexing, and return 6, right? So as for why it is printing the 6 this time is basically because I'm putting in this net loop. I'll take it away. 1 6, right? So this find will return the index of the element. So if you take something that's not there in the string, return this big number, right? This big number indicates that the element does not exist. That's what it means. But what it's actually returning is an std string of npos. This npos is something you need to know that this npos is a special character, right? Special thing that's provided by the C++ library. This will be returned when you don't find something in the string, right? So when you try to print it out, it will print this big number, right? It's because it's basically the maximum number that is representable by the unsigned 64-bit integer. But that's not the thing. This is what is being returned. This find function is also defined in a map. So when you have a map, yeah. So when you have a map, Okay, so there's a problem here because I'm trying to do something else. Okay, so that's the problem here. So the basic thing is when you have a map like this, you can search based on a key, right? So that's exactly why we use a map. We use a map because to have a logarithmic time lookup, so that in a database record you have a fast lookup instead of doing a linear search every time. So when you have a map over here, you can search based on the key, not on the value, right? So the first element is the key, and second element is the value, right? So you can basically find based on the key. So if the element is found, it will return an iterator. On a map, if the element is found, right? So if found, it returns element to the iterator. If not found, returns map.end. Now as you can see that this is the use case of end, right? In beginning we saw that the end points to the element that is after the last element, right? So when it returns something end, this is what it means. This is exactly where we use this. So when you do map dot find of 5 equal to map dot end, from now we say that element not found. Yeah, so yeah, this is very simple. So when you do map.find and check that whether it's equal to map.end, right? If it is equal to map.end, basically means that the element is not found, and that is exactly why I'll show you this. Yeah, I'll show you image. That's exactly why, as you can see that end always points to one element after that. There is no element in here. So when you do operations like find, it is very convenient for us to return the end iterator, end iterator, so that it says that the element is not found, right? So when you find an element, you can return the iterator to that. I mean, when the iterator is found here, so you can have an iterator to that, right? So you can have an iterator to this one. But if it is not found, you can basically do that to end, and it's very convenient for us to do this, right? When you it is very convenient for us because you don't have to return something like -1, right? Or you have to do something like a very big number, as you saw in the string example where it returns the maximum value representable that by the unsigned integer, right? So you don't have to do this magic stuff. You can just return end and it will be convenient for us. So that's exactly why iterators are very useful for us, right? So this map, wherever you use find or something like that, you can use find, and then you can deal with the iterators. If it is found, right? So if it is found, you have an iterator, right? So you have to dereference it. You should not forget that. So you should dereference it to use it. So map as an iterator, string also as an iterator. There's nothing much you have to be knowing about the string, right? So we can use also append. So name this also has an name dot append. So you can append characters to that. So if you do name dot append of yes, this will append the string of yes. This will append this character yes to the string at the last. Will append yes, I believe. So there are so many functions. You don't have to remember all this function. As you clearly saw that even I did not remember every function. You can always read the documentation so that to check that what the function actually does, and be very careful about what it returns. Does it return the size or the index, or does it return the iterator? Some functions return the iterators, some function does not return the iterators. Some function returns just the number or the index of the value, right? So we saw sequential containers today, associative containers, string, and then we also saw why should we using a reference and then cons to prevent copies from being made. So another thing I would like to mention at the last, as we are going to end the session, we also have something known as algorithm library, right? So we actually thought that we could complete this entire session within 2 hours of time, but actually it is taking more than that. This algorithm library, I have prepared a documentation where I have put most of the almost always use some algorithms. So I've used most commonly used functions from the algorithm library to in that documentation, right? So I'll also explain something. Okay, so uh, STL, if you type STL algorithms, uh, if you type STL algorithms, you'll get that. G4 is pretty beginner friendly, so I'm using this website. So you use algorithm, include algorithm for that, and you can see pretty good functions like Yeah, I'll use this function. Yeah, this is a very good function. So I'll take a now we'll look at an actual example. So I take a vector. I think it will be good if you go to code, right? So I'll just go to Visual Studio Code. I guess you don't need this. I just take int 2 comma 3 comma 4 comma 2 comma 5 comma 1 comma 9 comma 5 comma 7. So this is known as aggregate initialization. You can also initialize a vector by using this curly brackets, right? So to make it more readable, I'll just keep it so every single time you don't have to get the input from the user and then displace back all the elements. You can, while creating a vector, you can also specify some set of elements. So when you do a vector dot pushback of 5, as you can clearly see that this 5, okay, this 4 will go to this place, right? So this will be pushed back. So that's what is the pushback. So push it to the back end. So we have an vector over here. So I'll just type I'll just do a for loop over here. Auto it equals vector begin, right? So I'm really sorry if you hear the keyboard noise, because I have no other way as I said previously. So vector n and then this plus it ip cdc out of star it space, and then we'll type end line, right? This is convenient for us, and then I'll try to print it first. Wait, I guess it's not getting input from this file. Now you can see that this vector is being printed. I'll close this one. So 251956, this is the vector. Now we'll use some functions from the algorithm library. Okay, so we'll just comment out this one. I'm including. I'll use one or two functions. I'll show you how to use that. This function is called as reverse, std reverse. Okay, so this function basically reverses the array, reverses the container. Okay, so if you have a vector sequential container, right? So if you have a sequential container, and it will basically reverse elements, right? So in this function, it's taken some parameters, right? So that's parameters and iterator. That's exactly why I emphasized more on the iterator part. So for us to do that, we'll choose begin and vec end, right? So I'll now explain this. This is std's namespace. Reverse is the name of the function. Vec is the name of the object, which is vector. Dot begin is basically passing an iterator to the first element, and then vec.end is basically passing to the iterator to the last element after the last. So now this will reverse the entire entire container. If you don't want to reverse the entire container, instead if you want to use this only 3 elements, right? So 3 elements, you can do that by also saying begin plus 3. If you do this, begin and begin plus 3, right? So this is basically pointing a pointer to 2, and then another iterator pointing to this element. So this will reverse only this range. So the thing is reverse of first comma last. So whatever you mention here, this range of first and last will be reversed. So this is the best example I can think of at this time. So I'll just copy this code, and then I'm just building this. Yeah, pressing negative new. As you can see that first it is 251956, and now it is 152.956. But yeah, it's because I'm reversing plus 3. Instead I'll just make it end. So end. So this end is a member function. So now we are reversing the entire container. As we are reversing the entire container, as you can see now, 2521,956 goes to 659152. It has reversed the entire container, and this is exactly why we need iterators and to pass this to this one, right? So we also have another function called sort. This will sort. So you don't have to write your own sorting algorithm every single time. Now this looks like a very big relief, right? So also use sort, right? So and then you can copy this element. Now I'll run it. As you can see that 251956 first reversed, and then this container is now sorted 1255569. So this is a sorted element. So these two are basically like the tip of the iceberg of this algorithm library. There are so many number of functions in this algorithm library, most of which we won't be actually using, right? So only like around like 10 functions to 15 functions are the most commonly used functions, and all those 10 to 15 functions are covered clearly in the documentation which we prepared. So I'm just showing you a bit. So if you want to read more about that, you can basically read the documentation of this function. The things that you should actually check is, what does this function return, what does this function get inside. So this function returns a returns an iterator, I believe. So it returns a constant. Oh, it does not return anything. So it returns a void, right? So it does not return anything, and then it takes two elements. The two parameters are iterator to the first, iterator to the last element. The same goes for sort also. It does not return anything. Void return type. The first element, the underscore first is the first parameter. It is iterated to the vector, and the second one is also iterated to the last element. So it works like that. So there are so many functions in the algorithm library, which will be in the documentation part. So that's an algorithm library. We took so to recap everything, we took care of we saw how arrays, static arrays, CSL arrays, and how we do arrays in C++, and dynamic arrays, because we won't be using static arrays. So dynamic arrays is implemented using a class called vector. We saw how vector works, how to input and how to deal with input and output of vector, and then we saw iterators. Then we saw associative containers, where we dealt with map. Okay, so the difference between how in place and how do you insert an element, the square bracket operator. And then we now saw algorithms library. So before giving the end, I'll just give you one more thing. You can clearly see that using I64 equals long long. It is actually very common for us to do something known as hash define int long long. This is actually very bad. So as you can see that this define is basically a text replacement, right? So what it basically does is it finds all int in this entire document, and then it will return every int by text replacement to long. So I hope you guys have used text replacement, I believe. So if you press Ctrl F and then you'll use this. This is a bad thing. Instead of using, C++ does provide you a feature called this using this syntax. Okay, you basically use this using keyword, and then you can take anything in this. So I'll just make it a fit up anything you want. You will type name, right? And then type it as name2, yeah, name2. Now everywhere you use this name2, this will have a semantic analysis, so that this name is now long long. So instead of using hash define int as long long, you can use this one. This is much better. Some people also use hash type def. Type def. I have never used type def in my personal experience, but type def is also a thing, right? So this type def and int, instead of using these two things, you can basically use using. So I use I64. I64 means integer 64 bits. Long long is basically a 64-bit integer, and then U64 means unsigned 64. That is long long. Long long is 64-bit long, and then unsigned is basically say the assignedness of the bit. So I use I64, U64. That's very simple. So whenever you want to declare a variable of type I64, you type I64, and then when you want U64, and you can type U64. So before going to that, before ending the session, I'll ask for any doubts. And the thing that I have to say is, when you have this I64, it is a 64-bit integer, right? So even it has a limit. If it goes beyond the limit, we call it overflow. Or we are also on the other side, we have underflow. When you have overflow or underflow of integer, signed integer, it is undefined behavior. But the overflow or underflow of unsigned integers are not classified as undefined behavior. So you guys have to be careful about overflow and underflow, right? So in most of the questions, you will see that since the input is very large, you can output the answer with a modulus value. So you'll be using modular arithmetic to modulus the value so that the variable does not overflow, right? So you also guys have to look out for overflow and underflow. Okay, so you have this use this syntax, right? So also like one, I'll take one more minute and then I'll explain you another syntax where we use range based for loop. Yeah, this is the last thing. So like as you guys really saw that for this is very simple, right? So for I is 0, I less than vector size x plus I, and then you type series out of cuff I, right? So this is very convenient for us. This is a C style classic C style for loop, but we saw that in many cases this may not be useful, right? So we switch to this syntax where we use a iterator, and even this is very cumbersome. So to make it even very small, like very short, we have something known as range based for loop. So I'll take it uh, range based for loop, right? Range based for loop. This is a syntax for that. We basically type for in this we type auto ampersand, and guys, I think you will remember this ampersand is used here to make sure that we are not copying elements. As we saw in the first, we should never copy elements when you have a very big container, right? So auto ampersand element is basically this substitute of I or it, anything. You can name anything you want, name anything you want, name, right? And then this use a colon over here, right? Colon over here, and then use big. What this basically does is this will take each and every element one by one, starting from the first element from this vector, and then give it to this name, right? So the first element will be taken, this will be assigned to name. Second element will be taken 5 and will be assigned to name. Third element will be taken and will be assigned to name, right? So now we can choose to output that. So I'll name this element as of now. Now this will give the exact same. Yeah, so as you can clearly see that this is as output 1 2 5 5 6 9, and this range based for loop also outputs 1 2 5 5 6 9. So there are some disadvantages to this, because you cannot do something like a star element over here. Yeah, the basic thing is when you have this I over here, you know the index, right? So when you this I basically says that which element are we referring to. So if we say that yeah, if we say that if I is 2, then I'm basically referring to the third element. Since it's a zero based indexing, I equals 2 means that this is the third element. So you have control over which element you're actually accessing as of now. But in this case, you don't have access to that. You only have access to the element itself and not the index of it. So if you want the index, you have no other way other than to use this syntax. If you don't want the index, you can use anything. You can use the range based for loop or iterator. But if you want to use this iterator, and if you want to know the index also, there's one function called there are two ways to do that. You can basically do that it is iterator minus the first iterator. What is the first iterator to the vector is begin, right? So if you do that, auto size, I'll use index, right? So index. Yeah, when you do this, you're basically getting the index of the iterator. So iterator is the iterator, the current iterator, and we are subtracting the first iterator from this it. Now this will give a ptr-diff t. Now this ptr-diff t is basically integer, so you don't have to worry much about that, the type itself, because this type is from C compatibility mode. So this is also from C, right? So you don't have to worry much about that, because you're subtracting two pointers, or you're subtracting two elements which behaves like a pointer. So it basically element, so it's basically a number, right? So you can also use this index. You can use this. There will be nothing wrong with that. So if you want the index of it, you have to minus vector begin, which is the first iterator, minus its current iterator, so it will give the index. So if you want the index immediately, you use this syntax. If you don't want the index immediately, but if you want a control over the index, you can use this syntax. If you don't want the index itself, like for in this case, you're just printing the elements, right? So for you to print this element, you don't need the index itself. You just need to print every element one by one. So you can use this syntax. So auto ampersand for not copying, element is the name of the actual element that we're going to use this time. This one loop, one iteration, one colon over here, not semicolon, one colon, name of the container, std element, right? So if you have a map over here, so if you have, let's consider a map. If you have a map over here, so you have to use element dot first and space. Okay, I have space, sorry. So let's just use map dot element dot second. Now this makes sense, right? So one element in a map, I mean one actual element in the container of map is in pair, right? So it is a pair of key and values, so you print the first and the second element, right? So with this, I'm ending the stream, so I'll give five minutes time so that you can ask your doubts. The first thing that you need to know is we cannot actually cover the entire STL and then the working with me teaching the concepts of C++ also, because C++ itself is a very vast language, right? So we cannot actually do everything in a 2-hour time span. So even if you go and type in a YouTube channel, any YouTube video, the video will be like approximately 3 to 4 hours long. So since I tried my best to attempt at this stream so that I can do everything within 2 hours period of time. Actually, we were planning for 1.5 hours, but for me to explain everything from loops and functions to iterators, it's very hard for me to put it in words. As you can clearly saw that I was stammering at many points is because I cannot actually go inside and explain you how iterator actually works, right? So it's very hard for us. So please understand also that thing, because we cannot teach everything. But we can what I can promise you is that we'll be active in the Discord server. If you have any doubt in this, right? So if you're starting from this aggregate initialization to anything pushback, back, you can ask in the Discord server. If you feel that I'm not explaining something properly, you can also point me in the Discord, so I'll clearly explain. So because you'll have much more time and there'll be like one-to-one conversation. Don't DM me, please don't DM anyone. Just put it in the Discord server, because most of the people will also get benefited from that, right? So just understand that thing is, we cannot cover every single topic or every concept that is related to CP within 2 hours of time, right? So thank you for staying with us till this end of the session. And if there are any doubts, you can just post it in the chat. I'll just wait for 2 more minutes and then we'll just see how it works. Any doubts? Yeah, okay. I think Ritesh has already asked, can I learn STL without knowing much idea about DSA? Yeah, you can actually, you can. This session we did not focus much upon DSA, but we did have an attempt to teach most of the containers on the STL, right? So any doubts? Actually, Vishnu, that's the point, because in order for you guys to like understand everything within the span of 2 hours, even it's a tough challenge for you people, because you need time to process how a vector actually works. But before that, I actually went to another container, right? So take your time. You can ask any doubts in the Discord server if you want. You can also have the documentation. We prepared one for you people so that it's very beginner friendly, because without putting many jargons or very big words in that. So that's the best attempt that we can do. So I guess we are done with the stream, I guess. So any more doubts? Because I'll be closing the stream as of now. Okay then. So I guess there are no doubts and we are stop streaming. Thank you for attending, guys. So if you have any other doubts, you can post ping anyone on Discord. We'll be there to help you. And then we also have one more session next week. And since there are exams for the third year students, for some NPTEL, some off campus exam, we'll be conducting one session on Monday, right? So it's only change in next week alone. Like, we are not going to change the entire schedule for that. Since there's an exam on Sundays for seniors, the third year people, we'll be conducting on Monday or Tuesday. But we'll have every week, like we'll have one session every week on Sunday, either 4 p.m. or 5 p.m. The time may change, but we'll definitely have one session. The first week we have covered STL, right? So most of the people will learn STL on their own, no issues. But if you don't, you can ask the doubts. Next week we'll have one more topic. Third week we'll have one more topic. We are starting from the basics. That's the STL first week, and then we'll go to math concepts. We'll go to teach arrays, algorithms based on arrays, how array actually works. So we'll be teaching one concept by week. We'll be learning progressively, right? So thank you for sticking with us till the end. Thank you. See you later.